So this video is looking at simultaneous equations and the substitution method for solving simultaneous equations, and this is on page 28 of the textbook. So the steps here for the substitution method, it says use one equation to work out a formula for one variable. So essentially you're rearranging one of your equations to solve for one of the variables x or y or a or b or whatever you're given. Then substitute the formula for the variable into the other equation, solve the new equation, because by substituting the formula for the variable into the other equation, you're going to reduce it down to only have one variable now, and you solve for that variable in the new equation. And then substitute the solution, so the number that you've gotten, into the formula of one of the original equations, and then you check the values of both of the original equations. So just at the end you do a final check like we did with the last one. So here is example 14 from the textbook, again on page 28. So they've given us these two equations and they've asked to solve them by substitution. So step one was use one equation to work out a formula for one variable. So what they've done, they've written down and labelled the equations, equation 1 and equation 2. Now, they've rearranged equation 1 to make b the subject. So you can see they've got 2a plus b equals 3. They've subtracted the 2a both sides to move it over to the right hand side, and so here you've got that b equals 3 minus 2a. It wouldn't have mattered if they decided to solve originally for a or solve originally for b. In this case they would have solved for b because everything still remains as integers. If you solve for a, you would have had to divide everything by 2. You would have ended up with 3 on 2 minus b on 2. So you kind of just pick the one you're going to solve for based on what will be the simplest. What will be the simplest numbers to use in the further algebra. So now what they've got a value for b. So now substitute for b in 2. So they know b is equal to 3 minus 2a. So in equation 2, let's go back to equation 2. In equation 2 here, they know b is equal to 3 minus 2a. So they've substituted in here, they'll now have negative 5a plus 2 times 2 lots of all of this equals negative 12. And here we go. b equals 3 minus 2a, they've put it into the equation, there it is. So if you compare negative 5a plus 2 lots of b equals negative 12. Negative 12. Okay, so now they've just moved on to, I guess, collect like terms, expand the brackets here. So 2 times 3 is 6, 2 times negative 2a is negative 4a. And then what have they done next? They've subtracted 6 both sides, so ended up with negative 18 from the negative 12, and they've collected the terms of negative 5a and negative 4a to get negative 9a. And then divide by negative 9 both sides, a equals 2. Now, what they've done here, they've substituted a equals 2 into the equation 1a. Equation 1a was the one they used up here, where they found that b is equal to 3 minus 2a. So they've substituted a equals 2 into that, so you've got b equals 3 minus 2 times 2. And 3 minus 4 is b equals negative 1. So they've ended up with two values, a value for a, which they then use to find the value for b. They could have substituted that value for a into any of the other equations. They could have substituted it into equation 2 if they wanted. It would have just been a bit more rearranging the algebra, but they would have got the same results. So what they've done finally is check the values of a and b in the original equations. So taking the left hand side of equation 1, 2a plus b equals, well, a was 2, so 2 times 2 plus, and b was negative 1, 2 times 2 plus negative 1 equals 4 minus 1, which equals 3. And that 3 is equal to the right hand side of equation 1. So they've said here, okay, so it's still a true statement. And now equation 2, they've got negative 5a plus 2b equals negative 12. So the left-hand side here, negative 5a plus 2b equals negative 5 times 2 plus 2 times negative 1. And just solving it equals negative 12. Yep, all good. Often people write, before they write this step just here, they'll put left-hand, LHS, or left-hand side equals, and then they'll write the left-hand side, do your substitution, work it out, and then they get to the right-hand side answer, and they see equals RHS, equals right-hand side. So you're going through step by step saying, we've started with the left-hand side, we've substituted and evaluated, and we've ended with the right-hand side, so we've had a true statement. So sometimes it's good to do that as well, just because when you look at their solutions here, like if we erase all this, when you look at their solutions here, like this one, it's just a whole bunch of numbers. It doesn't read in a sensical way, really. It's just a bunch of numbers. But where we've got left-hand side, it tells you where you're starting, tells you what you're doing, and then you read across and you go, okay, so we've shown that the left-hand side is equal to the right-hand side. It's sort of a better way to do it. And only a few extra letters to write, really. So at the end they've said, write the solution. Simultaneous solution is a equals 2 and b equals negative 1. Good to summarise at the end what the solution is. As this is two lines crossing, you could also just say the simultaneous solution is, well, if this was x and y, in this case a could be the x-axis, b could be the y-axis. You could say, oops, if this is x and y, you could say 2, negative 1, or something like that, the point where they cross. But because it's not x and y, probably better to go with the a equals 2, b equals negative 1, because then you're saying which one is equal to which. There isn't the convention as we have with x and y, which says that the x value is first in the brackets and the y value is second.